Like there was a whole story today about China just landed on the far side of the moon. So they landed a probe over there.
Yeah, they did. So I think it was a reconnaissance mission to gather intel and data, which is probably why China's gone to that far side of the moon as well, because they're probably going to. It's a race to see who can capture ancient technology and then reverse engineer it and then weaponize it.
So what do these structures look like to you when you look at them?
Just dome structures there.
A dome?
There's domes. As a matter of fact, one of the astronauts, I think it was Neil Armstrong, if you get the declassified from the Freedom of Information Act documents that are the black box audio and the black box redacted text statement from NASA, which is available to the general public, Neil says, look at those convex structures down there. I bet the people in there never get out. And he's talking about dome structures on the moon. And this is an exact statement that was made that's in the black box audio, which I can provide you to the link to that as well.
Joe Rogan dropped a bombshell about the moon's newest discovery. He calls it the most important in decades. And here's why. Hidden pits might lead to ancient lava tubes, revealing secrets that could change human exploration forever. Imagine natural underground shelters waiting for us to build lunar bases, cut down radiation, and unlock the moon's hidden resources. This wild find shifts everything we thought we knew about our cosmic neighbor. Buckle up, because Rogan says it's about to get real. Discovery of strange holes on the moon.
Researchers believe they've discovered a location for a possible future base on the moon. Analysis of NASA data has found a cave believed to be about 80 meters long and 45 meters wide. That's a cool cave.
In 2007, the Japan Aerospace Exploration Agency, JAXA, launched the Selene spacecraft, affectionately named Kaguya, to study the moon in unprecedented detail. Sporting high-resolution cameras and advanced sensors, Kaguya peered at familiar lunar landscapes, but soon spotted something strange. Instead of only seeing the usual pockmarked craters, the images revealed dark holes scattered across the lunar surface. These holes, or pits, appeared nearly round, and unlike the craters formed by asteroid or comet impacts. Early measurements showed they were about 100 meters across and dipped roughly 50 meters into the moon's crust. Their sharp edges drew scientists' attention because they stood out among the typical bowl-shaped depressions. Even more intriguing was how the shadows shifted inside these pits, suggesting underground cavities below. At first, many thought these might simply be collapsed areas, caused by weak ground giving way. But as data poured in, researchers began to suspect that these holes could be windows into something much more elaborate. If you imagine a tunnel network running below the surface, then a pit's opening might be where the roof caved in, allowing cameras to glimpse deep into the moon's hidden interior. Further investigations using advanced orbital data reinforced these ideas. As the sun crossed the sky on different days, scientists noticed how the shadows inside the pits danced around, revealing changes in shape and depth that might point to larger hidden spaces. Some tried bouncing radar signals off the surface near these pits, hoping to detect echoes from below. Early results indicated that significant underground cavities could be attached to these lunar holes. Why all the excitement over a few pits on a surface covered in craters? It comes down to preservation. The moon doesn't have Earth-like weather, so once something forms below the surface, such as a volcanic tunnel, it can remain undisturbed for billions of years. If these holes indeed connect to subterranean cavities, we could be on the verge of exploring geological time capsules from the moon's earliest periods. Ultimately, these findings turned out to be just as dramatic as they seemed. Scientists realized that these openings might be connected to entire networks of lava tubes carved by volcanic flows in the moon's past. If we want to understand how the moon formed and whether it's suitable for human settlement, these pits could be the best doorways we have. Ancient lava tubes.
The moon originally was a big ball of magma. Through time, as the crust formed on the surface, the magma on the interior also slowly leaked to the surface.
Picture streams of molten lava beneath the moon's surface, flowing like a river of fire billions of years ago. As the top layers cooled first, hardened crusts formed a ceiling, while fiery currents continued moving below. Once the eruptions ceased, the remaining lava drained away, leaving behind hollow tunnels. In some places, the tunnel roofs eventually collapsed, resulting in the strange pits identified by Kaguya. On Earth, lava tubes exist in volcanic regions like Hawaii and Iceland. You might have heard of the Kazumura Cave in Hawaii, which is about 65 kilometers long, one of the largest and longest known lava tubes on our planet. However, the moon's lesser gravity means its lava tubes can become even larger, potentially spanning tens or even hundreds of kilometers, because they undergo fewer collapsing forces over time. Scientists love these lunar tubes for multiple reasons. First, they offer a protected environment shielded from meteorites, radiation, and temperature extremes. Second, because the interior of these tunnels undergoes minimal changes, it preserves its geological layers. That means we could find ultra-ancient rock inside, revealing details about the moon's fiery youth. Third, from the perspective of space agencies planning for lunar bases, these tubes could be near ideal. They already have structural roofs, the leftover rock from the old lava flow, which can provide insulation and protective shielding. In essence, discovering potential connections between these pits and lava tubes transforms them from curious features into prime real estate for future explorations. When humans or rovers venture into these tunnels, they might be the first beings to see rock untouched by sunlight or cosmic rays in billions of years. Imagine turning a corner in a dark tunnel to see prehistoric basalt flows or layers that even the Apollo astronauts never encountered. But there's more than just scientific curiosity at work. These tubes could be stuffed with hidden resources. Water ice, if present in certain cooler spots, might provide a lifeline for future moon dwellers. Key elements like oxygen, hydrogen, and metals could be harvested, reducing the cost of bringing supplies from Earth. This synergy of science and resource potential has turned the exploration of lunar lava tubes from a side note to a top priority, setting the stage for a new era of space missions. Lunar colonization.
Space tourism flight is currently underway. This is big news. You are now going to watch live images where tourists have been flown to the edge of space.
Living on the moon sounds exciting until you consider the countless dangers. There's cosmic radiation, solar flares, micrometeorites, temperature swings of hundreds of degrees, and no breathable air. Constructing bases above ground requires thick walls and extensive shielding, which can be risky and expensive. Enter these naturally protected lava tubes. In these tunnels, the overhead rock can be meters thick, blocking up to 82% of harmful cosmic radiation that would otherwise bombard the surface. The environment inside is also more stable in temperature, hovering around 20 to 25 degrees Celsius, compared to external extremes that can jump between scorching daytime highs over 120 degrees and nighttime lows around 170 degrees. Why does that matter for human explorers? Stability reduces the cost and complexity of heating or cooling habitats. Thin metallic walls or inflatable modules carefully installed within a lava tube's walls could maintain a consistent environment without needing massive amounts of energy for climate control. Protection from micrometeorites is a huge bonus. Tiny space rocks traveling at high speeds can puncture equipment, or worse, injure astronauts on the surface. But inside robust lava tubes, anyone inside has multiple layers of basaltic rock for cover. Some scientists suspect that given the right conditions, these tunnels might also trap or preserve water ice. That ice could be split into oxygen for breathing and hydrogen for rocket fuel. Suddenly, the possibility emerges of a semi-self-sustaining habitat, not entirely dependent on constant resupply from Earth. Furthermore, building down instead of up has engineering appeal. Above ground, you must transport structural materials from Earth or craft them from lunar resources. Below ground, the rock architecture is already there, shaped by volcanic processes. Explorers would only need to seal walls and install essential life support systems, saving tremendous effort. These reasons have captured the imaginations of space agencies worldwide. NASA, JAXA, the European Space Agency, ESA, the Indian Space Research Organization, ISRO, and especially China, have begun exploring how to transition from theoretical lava tube bases to real operational facilities. We stand at the brink of seeing if the moon can become a stepping stone to Mars or even a permanent outpost for humankind. China's grand ambitions and Chang'e missions. China has taken bold steps in exploring the moon by launching a series of missions, all named Chang'e after the Chinese moon goddess. Over the years, these missions have grown in sophistication, from orbiters to landers, rovers, sample return spacecraft, and ongoing plans for establishing a semi-permanent base. One major focus of China's program is the South Pole of the Moon, believed to hold pockets of permanently shadowed regions where water ice might exist. But for China, these mysterious lunar pits are equally compelling. While top-tier agencies contributed to the knowledge of these subterranean features, China's approach stands out for its direct emphasis on forging a path to underground lunar bases. Chang'e 7, which is on the timeline for the mid-2020s, aims to do more detailed surveys of specific pits and their corridors. Specialized rovers with cameras and radar instruments could drive right up to the edges of these holes, scanning for structural stability, resource deposits, and possible entry routes. If such a rover can rappel or lower itself into a pit, it might become the first machine to explore an underground lunar chamber up close. Within a few years, Chang'e 8 might follow up by experimenting with construction technologies and 3D printing inside or near these pits. Concepts include inflatable habitats that expand within the lava tubes and advanced rovers that deploy supportive materials along the tube walls. Meanwhile, China is collaborating with Russia on drilling techniques to analyze soil composition and structural safety inside these pits. China's strategic interests are both scientific and geopolitical. Proving the feasibility of building bases in lava tubes could help them plant their flag as a frontrunner in lunar settlement. Gaining first-hand resources like helium-3, which is considered a potential fusion fuel, and establishing permanent stations may grant them an edge in the fierce competition with other nations. Critics and admirers alike see these missions as giant leaps, not only for China, but for global space exploration. If China manages to bring back details about these subterranean structures, that data could shape how every other space agency plans future missions. The result? A potential gold rush for the moon's hidden treasures, redefining how we see the lunar environment. The Lunar Maria, dark plains from ancient eruptions. Look up at the moon on a clear night, and you'll see light and dark regions forming the face we interpret as the man in the moon. Those darker patches are called Maria, Latin for seas. Early astronomers mistakenly thought they were bodies of water. We now know that they're vast basaltic plains, remnants of massive volcanic eruptions that shaped the moon long ago. These giant plains cover about 16% of the lunar surface and stand out because they're flatter, darker, and smoother than the rest of the moon's crater-littered highlands. Scientists believe that when the moon was more geologically active, molten rock found weak spots on its surface and flooded impact basins. Over time, these cooled to form the dark basalt floors of the Maria. Though not as dramatic as the deep lava tubes, the Maria remain fascinating for scientists. They can indicate how the moon cooled and how intense volcanism might have been in different epochs. By analyzing minerals from different parts of the Maria, researchers have established that volcanic activity on the moon continued far longer than previously assumed. Some basalt samples date to around 1.1 billion years old, which means the moon had volcanic episodes lasting billions of years, not all crammed into a tight window soon after its formation. China, for example, picked Oceanus Procellarum as the landing site for Chang'e 5. This region, known as the Ocean of Storms, had never before provided direct samples for laboratories on Earth. By retrieving roughly 1.7 kilograms of basalt, Chang'e 5 revealed that some parts of the moon formed more recently than scientists had thought. These discoveries forced researchers to update their theories on how the moon cooled and how it might still hold internal heat sources. The interest in these basaltic plains isn't just academic. Their flatness is a convenient landing field for robotic and crewed missions. Incorporating a station near or inside a lunar lava tube adjacent to these plains could be practical, ensuring a stable location and close proximity to mineral-rich regions. Additionally, the ancient basalt might preserve a record of cosmic impacts over billions of years, acting like a giant hard drive that stores the solar system's history. Next time you stare at the moon, remember that the dark patches are more than mere decoration. They are geological diaries that speak of ancient lava flows, deep eruptions, and an evolving satellite that still hides many secrets beneath its surface. Significance for human exploration and resource use. Why pour so much time and money into exploring old lava flows and weird holes on a desolate rock? Because we suspect the moon to be a stepping stone for humankind's expansion into space. If we can set up outposts on the moon to do research, mine resources, and prepare future missions to Mars or beyond, then we may usher in a new era of cosmic development. One major advantage involves resource harvesting. For instance, water ice, which might be found in permanently shadowed polar craters or in shielded lava tube pockets, can be split into hydrogen and oxygen. Hydrogen can power rockets, while oxygen is essential for breathing. Transporting water from Earth is both costly and limiting, so local resources could cut costs drastically. We also find potential in helium-3, an isotope that might be suitable for future nuclear fusion reactors. While still speculative in energy terms, having a place to gather or process helium-3 on site could attract major investment. Rare earth elements used in electronic devices might also lie in certain lunar regions, reducing the need for Earth-based mining. Structurally, using the natural geometry of caverns and tubes is just plain smart. Digging or building large enclosures on the lunar surface demands heavy machinery, protective materials, and complex designs. But if we slip inside ready-made basalt bunkers, we have a head start. We can then direct resources toward outfitting those spaces with life support systems and scientific instruments. It's not just about humans living neatly underground. Robotic missions would likely do the first heavy lifting, digging deeper tunnels, scanning for hazards, and building infrastructure. Over time, people might live in modular habitats embedded in the safest parts of these lava tubes, venturing outside in suits or rovers for scientific tasks. This synergy of geology, technology, and ambition underscores that lunar exploration isn't a mere repetition of Apollo's historical footsteps. We're not content to just plant flags and gather rocks. We need safe, long-term habitats to continue scientific research and open the door to commercial ventures, ranging from space tourism to advanced manufacturing that thrives in low-gravity environments. Thus, that lonely satellite we gaze at in the night sky might become a bustling domain of mining sites, laboratories, and cosmic pioneers. It all starts with the surprising potential of these hidden holes and tunnels. Missions pioneering lunar pit exploration. Multiple missions are slated or proposed to further investigate these pits and tubes, ranging from Japan's SLIM, Smart Lander, for investigating Moon, to India-Japan's collaborative LUPEX, Lunar Polar Exploration Mission, and NASA's Artemis program, JAXA's SLIM. The Moon Sniper aims for ultra-precise landings, about 100 meters accuracy on rugged lunar terrain, a big leap from older missions. This level of control matters because if we want to explore a pit's interior, we need to land right next to it, not kilometers away. One key target area might be near the Shiori crater, known for exposed mantle materials that could help scientists understand the Moon's deeper layers. A collaboration between the Indian Space Research Organization, ISRO, and JAXA, LUPEX, focuses on finding and studying water ice near the polar regions. Polar craters and pits may hold ice deposits, so the mission will carry specialized instruments for drilling and analyzing volatiles. Mastering landings in tricky polar areas is a major challenge, but if successful, LUPEX could pave the way for discovering easily accessible ice and exploring the still mysterious underside of pit entrances. NASA's Artemis program aims to return humans to the Moon, specifically targeting the South Pole. Its mobility relies on advanced technologies like the Human Landing System, HLS. SpaceX's Starship has been selected to ferry astronauts from lunar orbit down to the surface, potentially near resource-rich or geologically interesting sites. The ultimate goal is longer stays on the Moon, requiring robust habitats. That means exploring feasible locations, including lava tube openings. These missions emphasize NASA's approach: gather proof-of-concept data, test new landers, and confirm that we can utilize local resources. The knowledge gathered can then be leveraged in future expansions, from short-term labs to permanent research stations. Each of these missions teaches us something fresh. JAXA's SLIM could open the door for pinpoint exploration of known pits. LUPEX might reveal exactly how much water or other materials lurk in the shadows. Artemis, with its broader scope, might lead to the first footprints near a pit's edge, capturing images that spark public imagination worldwide. Step by step, we're inching closer to unraveling the secrets of these lunar gateways. Inside a lava tube habitat. Let's imagine that the planning has paid off, and an international team of astronauts is about to enter a crater that leads to a lava tube. A robotic scout has already mapped the interior, confirming a somewhat stable path forward. As the crew descends into the pit, the sunlight fades, replaced by the faint glow of portable LED lamps. Mixed feelings of excitement and awe fill the air. No human has ever ventured into a realm this ancient and untouched. Within the tube, the temperature doesn't wildly fluctuate the way it does on the surface. The astronauts notice the rough basalt walls shaped by flowing lava eons ago. Here and there, they see cracks or unusual rock patterns that might contain trapped gases or water ice. The environment is still hostile. There's no breathable air after all, but the cosmic rays and micrometeorite hazards are drastically reduced thanks to the thick overhead rock. They walk further in, setting up temporary lights and scanning instruments. The ground is somewhat uneven, revealing layers of cooled lava that once formed a raging underground river. Geological data floods back to Earth, measurement of basalt layers, possible mineral veins, and hints of water. Meanwhile, scientists in mission control track every step, prepared for any risk of sudden collapses or unexplained hazards. With stable footing confirmed, the next stage might see an inflatable habitat or a 3D printed module installed inside. Over time, the crew positions advanced life support systems, linking them to small nuclear or solar power units. Because heat is more uniform inside these tubes, insulating the habitat is easier, saving energy. Potential pockets or ridges in the walls serve as anchor points for cables, walkways, or even farmland modules for growing vegetables and herbs. It sounds futuristic, but every step of this scenario is within the realm of possibility if these pits and lava tubes prove stable. Over the next few decades, repeated missions could expand an initial pit outpost into a network of living and research sections, akin to an underground city on Earth. Astronauts would exist primarily within these tunnels, emerging for short forays on the surface to gather samples, run experiments, or greet visiting spacecraft. And all of it stems from the simple but game-changing discovery of these lunar holes by Kaguya back in 2007. Challenges and unknowns. While the dream of forging a new home under a lunar mountain of basalt is thrilling, we shouldn't overlook the hurdles. For instance, scientists aren't entirely sure how stable these tube ceilings are. A catastrophic collapse could be lethal, making structural analysis a must. Even if the caves are stable, dust is another problem. Lunar regolith is fine and abrasive, seeping into equipment and wreaking havoc on moving parts. Temperature is more stable inside the tubes, but it's still very cold. Habitats would need heating systems, although less than on the surface. Another challenge is the unknown layout of these tubes. Some might extend for kilometers, while others end in narrow passages or labyrinths, complicating planning for large-scale bases. Exploring a pitch-black, winding tunnel on the moon is no small feat. We need advanced rovers or drones equipped with powerful lights, robust communication links, and the ability to handle sharp basalt edges. If we lose contact inside a tube, retrieving the rover could be nearly impossible. Radiation levels, while reduced compared to the surface, are not zero. Basalt can shield much of it, but cosmic rays are energetic and can penetrate thick walls. Aggregating soil or using specialized materials might be necessary for added protection. Resource distribution, another unknown, affects how valuable a tube might be. We suspect some caves or pits might hold higher water ice levels, but that's not confirmed. Missions designed to measure these deposits, such as using ground-penetrating radar, must succeed before we invest in outfitting a tube for permanent occupation. Finally, there's the big question of cost and cooperation. Building and sustaining a lunar base, even with natural shelter, demands years of international collaboration and enormous budgets. Political will can fluctuate, and resource competition may become complicated if multiple nations zero in on the same prime pit locations. Rules of how to share or claim these areas might need updates from the Outer Space Treaty. Despite these challenges, the excitement remains. Humanity is drawn to the unknown, and these pits are precisely that. Our success hinges on robust engineering, wise resource management, and continued interest in pushing boundaries, both literal and figurative, on the moon and beyond. The future of lunar exploration. Countless experts say that these lunar pits and lava tubes could define the future of space travel for the next century. Early plans to return to the moon, like NASA's Artemis program, JAXA's Slim Lander, India-Japan's LUPEX, and China's Chang'e missions, signal a global desire to transform the moon into a stepping stone for interplanetary exploration. The days of single flag-planting missions are over. We're entering a period of building infrastructure. What does that look like over the coming decades? Possibly multiple permanent outposts scattered around the lunar surface, each specializing in scientific study, resource extraction, or even tourism. Some outposts may be hidden underground in ancient lava tubes, providing safer living spaces. Others may sit on crater rims near the poles, harnessing sunlight for reliable solar energy. Eventually, these separate stations might connect with rovers, rail systems, or communication hubs, forming a more unified lunar network. Such expansion can dramatically lower costs for deeper expeditions, like sending crewed missions onward to Mars. If the moon becomes a place to refuel, build, or resupply, the entire solar system opens up in ways previously thought impossible. The knowledge gained from establishing bases in tough conditions, low gravity, radiation hazards, alien geology will feed directly into the challenges of exploring other worlds. From a purely scientific viewpoint, exploring hidden tunnels beneath the moon's surface is like stepping into a museum dedicated to cosmic history. Studying basalt layers, investigating possible water ice, and analyzing the remnants of ancient volcanic eruptions can tell us much about how the Earth-Moon system formed. This raises new questions about how our planet might have looked in its earliest days, and whether the processes that shaped the moon might have parallels elsewhere in the solar system. For future generations, the presence of lunar colonies, especially if they nestle in lava tubes, would symbolize humanity's shift from a single-planet species to a multi-planet one. The technology developed, like 3D-printed habitats, advanced life support systems, and innovative engineering methods, could also benefit life back on Earth. We might find more efficient construction techniques, new ways to recycle water, or ways to protect against radiation that will have applications in fields ranging from disaster relief to nuclear safety. No single event underscores this potential more than the discovery of those strange holes. They triggered an avalanche of scientific interest, rethinking the moon as not just a cratered desert, but a labyrinth of hidden corridors. This awakening still unfolds, and every new mission adds another piece to the puzzle. Perhaps in a few decades, a group of explorers will broadcast live from inside a lunar lava tube, unveiling the wonders concealed beneath the lunar crust. That broadcast might unify our planet, reminding us that even in an era of many differences, curiosity and exploration can bring humanity together.